This video is going to review the very end of Chapter 5, which was the final piece of all of the things that we did with quadratics, functions that were parabolas. And we're going to do one that is solving, and we're going to talk about how you can solve it either graphically or algebraically, and then a couple modeling problems where you're given particular information and asked to write the equation of the quadratic. So we're going to start off with this one. It says you are to solve this quadratic inequality. First thing you want to do, no matter which technique you're going to use, is you need to get it in standard form. So we're going to bring that negative 3 over. So we're going to have 2x squared minus 7x plus 3 is greater than or equal to 0. So what this is saying from a visual point of view, from a graphical point of view, it wants to know when the parabola is above the x-axis, because we're looking for when it is greater than. So if you think about your parabola, we know this parabola is going to open up. So we're trying to figure out when does this parabola, when is it above the x-axis? So somewhere in here we have to figure out where does it actually equal 0, where does it touch the x-axis, so we can then figure out, well, when is it going to be above that x-axis? So the best way to do this is to graph it, or is to factor it, so that we can see what it looks like when you graph it. So let's factor it, and they will be nice and factorable when you're asked to do these. To find, we called them in class, we called them critical values. Those were the places where it crossed the axis. Those are the most important pieces of information here. So we have a 2x and an x. It is minus and a minus. It is going to be minus 1 and minus 3. You can check that by foiling it to make sure that we factored it correctly. And we get two x-intercepts. We get an x-intercept of 1/2. That's what makes this piece equal to 0. And an x-intercept of 3. So what that tells me is my parabola visually would cross the x-axis at x equals 1/2 and x equals 3. So that means that my y-axis is somewhere around here. Another way to do it, if you don't want to do it from a visual standpoint, is you can make a little number line and say, here are your two places where it equals 0, at 1/2 and 3. We want to know before 1/2, where is it? Is it above the x-axis or below? We want to know between 1/2 and 3, is it above or below? And we want to know about after 3. You can do this algebraically, or you can do it visually. Visually would just be look at the picture. Look at what you drew over here and see that it starts out above, and then after it gets 1/2, it goes below the axis, and then after 3, it goes back to above the axis. Algebraically, we can pick x values. If we pick any x values that's less than 1/2, pick 0, make it easy on yourself, and put it into this value, we should get a positive result. That tells me that my y value is positive, meaning that the y's are positive when it's above the x-axis. If I pick any number between 1/2 and 3, like 1 or 2, I should get a negative result. Again, I really don't need to do a lot of this work by hand. I know what it looks like. I understand that this parabola goes from above the axis to below the axis to back above the axis. This particular problem wanted to know when it's above the x-axis, or when does it have a positive y value. So it has a positive y values at the ends. There are a couple ways to write your answers, and I would accept either one on a test. Either you can write it like this in an inequality notation. We would say that it is when it is less than or equal to 1/2, or when it is greater than or equal to 3. The reason I put the or equal to is because the original problem had the equal to. That's telling me I want to include when it equals 0, not just when it's bigger than 0, but also when it equals 0, which happens at 1/2 and at 3. So this is one way to write your answer. We can say that my parabola is above the x-axis whenever it's prior to 1/2 and equal to 1/2, or 3 or larger. Another way to write that is in more of an interval notation, is we can say from negative infinity to 1/2, and I use what I'm saying with the brackets is I'm counting that number. That's why I use a bracket instead of parentheses. And from 3 to infinity. So this is saying when the numbers are 1/2 or less, or the numbers are 3 or bigger, those are the places where my parabola has a value of y bigger than 0. It is above the x-axis. So you kind of notice I kind of merged techniques here. I thought about it a little bit visually. I also thought about it a little algebraically. You really are doing a little bit of both. Once you understand what a parabola looks like, it really helps you write your answer and get your answer faster than doing as much work by hand. The other thing we did at the very end of the chapter is we did quadratic modeling, which essentially is given a couple pieces of information about your parabola, we should be able to write an equation in a particular form. So I have two examples up here, the two examples that we would have done together in class. I have one that's a vertex form and one that's an intercept form. So I'm going to start with the vertex form. Just to remind you what vertex form was, this was vertex form. The nice thing about vertex form is it was the one that you could immediately look at it and know what the vertex is without using any special formula, without doing a lot of extra work. So this particular parabola has a vertex at -4, 6. What that means is, when I look at my parentheses, if the vertex is at -4, then in parentheses it must be x plus 4, because it's always the opposite sign in parentheses. And then if the y value is 6, that means we have a plus 6 out here. So that's the first thing that we need to write down. We need to take this vertex information and fill in the h and the k part of the formula. The second piece is we have another point. And the reason we have another point is it helps us figure out the a value, because I'm not done yet until I know what a is. What I'm going to do is I'm going to take that point, this -1 is your x and 9 is your y, I'm going to plug those in and solve for a. So I'm going to put a 9 in for y. I'm going to put a -1 in for x. I do have to follow order of operations, so I have to do what's in parentheses first. So I get -1 plus 4 is 3. I have to square it, so 3 squared is 9, so I get 9a plus 6 equals 9. And now I want to solve a basic equation. So I'm going to subtract 6. I get 3 equals 9a, divide by 9. A is a third. So what that means is my final answer is y equals 1/3 x plus 4 squared plus 6. And the nice thing about these problems is if you want to check your work, graph that parabola on your calculator. Go on your calculator, type in 1/3 times x plus 4 squared plus 1 plus 6. What you should see is a parabola that opens up, because we found the a value to be positive. We should also see the vertex is at -4, 6. We also should see that it does look like it goes through the point -1, 9. Or you could use your trace button, your value button, to see that when you plug -1 in for x, you get 9 out for y. So you have that visual way to check your work. The next one, similar process, but now we're working with a different form, so we have a little bit different information in the beginning. We are working with intercept form, so they have to tell us about the intercepts. The intercepts for this particular parabola are -10 and -8. Now, intercept form, let me write down what intercept form was for you, so you can remember the generic form of it. This was intercept form. When I plug in my intercept, it's like you're finding the solution. You're writing the solution. If -10 is the 0 or the solution or the intercept, then that means in parentheses my factor should be x plus 10. If my intercept is at -8, then my factor should be x plus 8. Because the intercept is what makes the factor 0. So if I put -10 into the first parentheses, I get 0. Again, I have almost enough information, but have not found a yet, so I have to use my point. So that's why I give you this extra piece of information. This extra point is there simply to help you find that a value, that's beginning value. So I'm going to plug in -15 for y. I'm going to plug -7 in for x, and notice I have to plug it in 2 places in this one. So I have to put it there and there. I'm going to do what's in parentheses first. So I have -7 plus 10 is 3. -7 plus 8 is 1. So I have -15 equals, if I multiply 3 times 1, I get 3a. Divide by 3. I get a to be -1/5, or excuse me, -5, going backwards, -5. What that a value tells me is my parabola opens downwards. It is also much narrower than your basic parabola. So my final answer is -5, x plus 10, x plus 8. Doesn't matter which one you put first, the x plus 10 or the x plus 8. And again, if you want to check your work, you have your calculator, you want to graph your final answer, the y equals -5, x plus 10, x plus 8, on your calculator. What you should see is that it crosses the x-axis at -10 and at -8. You should also see that it opens down, that it is pretty skinny compared to your basic parabola, and you should see that if you put -7 in, you get -15. You should see that point on your graph, or you should be able to use either your value button or your trace button to confirm that that really is a point on your graph. So again, with both of these, your calculator serves as a way to check your work, to see, was it making sense the way I wrote it with my form, and is it making sense the a value that I found? Does it match the picture that I'm seeing? So hopefully those, combined with what we did earlier, will help you get ready for the test that is all over quadratic equations and their formulas.